Hello and welcome to this video guide on how to use Payara Micro with Kubernetes on Amazon Web Services. My name is Fabio Turizo and I'm a Senior Service Engineer working for Payara Services Limited. Before we start, you will be required to have basic knowledge of how Amazon Web Services works, in particular how to manage EC2 instances, how our load balancers configure, and general VPC management concepts. Also, since we are talking about Kubernetes, you will be required to know how Docker containers work, and specifically how new images can be registered to a Docker registry. And lastly, you will require to know the basic concepts of Kubernetes, that is, how to create and manage pods, how to create and manage deployments and services as well. So you'll learn today three things. First, you'll learn how to provision a new Kubernetes cluster in Amazon Web Services via its elastic Kubernetes service. Two, you will learn how to prepare a Payara Micro Kubernetes ready Docker image, and you will learn how to use that image in order to provision a new Payara Micro deployment in the cluster that we'll prepare. So, in order to execute these instructions on your end, you will be required to have installed the Amazon Web Services command line interface utilities on your local machine. You will also be required to have access to the EKS CTL utility, which is a separate utility used by the EKS service to interact with existing clusters and create new clusters. You will also be required to have a local Docker installation because we'll create our own Payara Micro image. And lastly, you will be required to have a valid Qt CTL utility. For the purposes of this example, we'll use version 1.11, but on your end, you can depend on any version you want. The first step in this guide will be to correctly set up our AWS account. And we need to do two things. One, to create a valid IAM user account, and we'll use this user account to set up its credentials locally with the AWS command line interface. Okay, now switch up to the Amazon Web Service console. So you can see here that I am on the Identity and Access Management or IAM dashboard, and I'll proceed to add a new user. So my user's name will be kube administrator. I'll set up its access type as programmatic access. Next, I'll set up three existing policies directly to this user. So the first policy is the administrator access job function policy. And then I'll search for the EKS moniker. So I can attach the Amazon EKS cluster policy and Amazon EKS service policies. So no tags to configure. And I'll proceed to create my user then. So you can see here that the Amazon Web Service console is giving me the access key ID and the secret access key, which I will use to immediately configure my command line interface locally. So for the purposes of this demonstration, I'll be using Microsoft Visual Studio Code, and I have raised a terminal window here. So I'll fire up the AWS configure command. And the first thing is that it will ask me for the access key ID. Then it'll ask me for the secret access key. The default region name, which is US, was 2, and the default output format, which is JSON. And that's it. Well, now let's start our cluster provisioning. So the first step that we need to take is to create a new Kubernetes cluster. And when using Amazon Web Services, there are multiple ways to create a cluster. And the easiest way is just to head straight to the web console, to the Amazon Container Services. And here on the clusters under the EKS section, then you can just simply fire the create cluster option, and then you can specify the parameters that you need. However, I consider that using the EKS CTL utility on the command line it's much better due to the range of options you have. So I'll start by using the create cluster command, and I'll specify the name of my new cluster, which will be named demo cluster. The Kubernetes version for this cluster, which will be 1.11. The starting number of nodes will be 3 nodes. The region for this cluster, which will be US West 2. And finally, the node type. So in this case, Amazon Web Services EKS clusters, you provision nodes using EC2 instances. So you can specify at cluster creation which is the size of the instances that will be provisioned as the nodes of this cluster. So I will use the T2.medium size. And then my cluster will start its initialization. So you can see here that it is contacting the Amazon Web Service infrastructure. It's evaluating the subnets available to creation for the nodes. It will create a starting node group, and then it will create something called a CloudFormation stack, which will be used by Amazon Web Service in order to provision the VPC, security groups, and other sorts of components that will be used internally by the Amazon Web Services infrastructure. Lastly, it will create the control plane for the demo cluster as well on the CloudFormation stack. So this will take a few minutes. So after a while, our cluster will be created successfully and correctly initialized. So we can go here to the Amazon Web Services web console, and under the Amazon Container Services dashboard on the Amazon EKS service, we can see that our cluster is reported as active, and you can see here all relevant data of the cluster and the networking resources being used to provision the cluster as well. Moreover, you can go to the Amazon EC2 dashboard and see here that there are 3 new instances that are used in order to provision the nodes of our cluster. You can see that the instances are of size T2 medium. And we can also go to the VPC configuration and see that there is a new VPC that corresponds to the network that will be used to manage the cluster communication as well. Moreover, you can also go to the CloudFormation dashboard and see here that there are 2 new cloud stacks. One is the stack that is used for the cluster. This is in order to create and configure new VPCs and resources for the cluster. And the other is the node group that is to manage all node group configurations in the case that you want to create new node groups for the cluster. So we can go back here, and in order to check out our cluster, it's correctly configured, we can just simply run kubectl get nodes. And you can see here that the 3 nodes that correspond to the EC2 instances are reported as ready, and they have been correctly configured, and they correspond to nodes of Kubernetes B 1.11. Okay, so the next step will be to review the sample application that we will deploy in the cluster. So here on my Visual Studio Code editor, I have the files for the sample application. So you can observe here that this is a Maven project which has the Java EE Web API, the MicroProfile API, and the JCache API as dependencies. And it just simply exposes a series of REST services in order to interact with sample entities. So in this case, we have a user data endpoint that allows me to create and retrieve users and to list all the users that are stored currently on the service. So to do this, I have a user data entity which has simply an ID, a name, an organization, and I'm also tracking which instance of the cluster it's storing this user. So how do you obtain the name of the instance in the cluster? Well, I use this on the user data service component, and I have here a dependency to another component called the info service, which is an instance of the instance info service component. And this is a singleton that uses the Payara Micro API. This is a proprietary class of the Payara public API in order to retrieve the current instance name at runtime. So all of these applications endpoints are exposed and will be available to the clients that will call this application. Okay, the next step will be to create a new Docker image that will use the sample application. So here on my code editor, I have prepared a Docker file with two simple instructions. One to depend from the current official Payara Micro image and on release 5.192. And the second instruction would be to copy the application's WAR file to the opt Payara deployments directory inside the container. So this is in order to make sure that when the container starts and launch the Payara Micro process, it will scan for this directory, take all WAR files and artifacts inside it and deploy them. So let's proceed to provision our image. So first, let's build our application. And now let's build our local image. So I'll use docker build and I'll assign the following tag: Payara / cluster demo, and I'll use the current directory. Now I'll load this image to the Amazon Elastic Container Registry service. I'll start by creating a new repository which will correspond to the same image on my local machine. So this repository will be named Payara Cluster Demo. And I'll copy the URI of this repository in order to tag it locally. So in order to push this image to this remote repository, I have to follow 3 steps. The first one is to log in using the Docker daemon. And the easiest way to establish this connection to the remote repository is by using the Amazon Web Services ECR command line utility. So I have to do that by enclosing the outcome of this command into evaluation variable. So I'll run the get login command, use the no include email argument, and establish that the region that I'm connecting to is the US West 2. Okay, so with this I can see that the login succeed, and now I'll tag it my image. So I'll run the docker tag command and I'll specify that I'm tagging the Payara cluster demo latest tag, and I will reference the tag in my remote repository by using its URI and specify it the same latest tag. And finally, I'll push this tag to my repository. And after a few minutes, you can see that the operation has been completed successfully. So if I go here to the repository, I can see here that the latest tag has been uploaded without issues. So before we proceed to provision our cluster, let's test this image first. And we'll do this by launching a new Kubernetes pod that starts a new Payara Micro instance using our sample application. So the easiest way to launch a Kubernetes pod is to use a YAML specification file. So here I have this demo pod YAML file, which defines a pod name demo pod, of course, and it only has one container that depends on the image that we uploaded to our ECR repository. So we are mapping the container port to 8080. We are defining a new environment variable that will be used for starting the Payara Micro instance, named pod name, and we're extracting its value from the metadata of the pod. As you can see here, the arguments that I'm passing to the container, which will be used by Payara Micro in order to launch the new instance, the name of the Payara Micro instance, which will be a combination of the K8S prefix and the name of the pod, and assign the cluster name. This is the data grid cluster that will be conformed by this Payara Micro instance to demo, and deploying the cluster demo application that I have already shipped within the image binaries. And then I'm assigning the context root of the application to the root of the server. And that's it. Let's launch our pod then by using the kubectl apply command and specify the name of the YAML definitions of our object. So in this case, it's the demo pod YAML file. With this, the pod should be created. Let's verify that the pod is running with the get pod command, and I'll pass the name of the pod. You can see here that the pod is running without issues. And finally, let's verify that the Docker container inside it's working without issues and the Payara Micro instance has started correctly. So I'll use the logs command and follow the demo pod container. And I can see here that the Payara Micro instance has started without issues. You can see here that it started a single instance cluster, and the name of this instance is K8S demo pod as we define in our YAML file. And you can see that it's initializing these REST endpoints as defined in our application. So with this, we can verify that our image is working. So let's quickly delete this pod. Okay, having tested our pod, the next step will be to provision our cluster by using a Kubernetes deployment. I have this demo deployment YAML specification file, which allows me to define a sample deployment with the following definitions. First, I want 3 nodes for the replica set that will be created by the deployment, and it will be applied to all pods with the level app and value cluster demo. And therefore, I configure my deployment to apply these labels to the pods that will be created. So these pods will contain only one container, which will be the same container that I defined for my demo pod. It will use the same image, it will be mapped to the same port, and it will predefine the same pod name environment variable. And the arguments used to run this container will be the same, but as you can notice here, I'm using the cluster mode Payara Micro argument. With this, I can specify that all instances of Payara Micro will start up and will use the Kubernetes discovery mode. That means that I will talk directly to the Kubernetes control plane and look for all the Payara Micro instances living in containers that live in pods in the Kubernetes cluster. This is automatic and it uses some, assumptions. First, that you are running on the default namespace, which we are doing for this example. And second, that the pods and objects being used by the deployment have access to the control plane. And in order to grant that access, we have to configure a specific cluster role binding definition, which we have here in the RBAC YAML specification file. This file contains a role binding that ties the view cluster role to the default service account used by the Kubernetes clients that are connecting. So the first thing that we need to do is to apply this definition, and then I'll use the EKS RBAC YAML. Now let's create our deployment. To do this, we'll apply the EKS demo deployment YAML file. You can verify that the deployment has been created, and let's check the status by using the kubectl get command. And you can see here that there are 3 pods attached to the replica set. All of them are up to date and available. And let's quickly get a look at these pods. And you can see here that our pods had been assigned the correct name and are running without issues. Let's inspect the inside of one of these pods in order to verify that the Payara Micro instances has been correctly initialized. So copy this. And you can see here that the instances have been initialized correctly. However, there is an issue, which is that the data grid reports that only one instance is part of the cluster. So what are the other two instances that are part of the other two pods? Well, in this case, even though we had configured the correct discovery mode for Payara Micro, and we had configured our cluster role binding, the instances can't talk to each other because they are isolated in the network. We need a service that allows instances to discover each other. And in order to do this, we'll provision a load balancer in the Kubernetes cluster by using this YAML specification file, demo service YAML. It defines a service component, which is of type load balancer, and named demo service. And the only thing that it does is that it selects all pods with the app selector set to cluster demo, which is the label that we have been using for our pods. And then we'll assign a new pod mapping that corresponds to an HTTP port on port 80 and maps to the local port of our Payara Micro installations, which are 8080, and the corresponding port in the provisioned EC2 instance that will listen to HTTP requests. So in order to apply this service, let's call the kubectl apply. Demo service YAML. And now let's reprovision our deployment. So let's delete the deployment first. And let's reapply that. Okay, so let's check out the state of our pods. And let's inspect one of them. So logs-f. And you can see here that the instance is deploying the application. And here you can verify that on the data grid status, you can check that there are 3 instances, one for each corresponding Payara Micro instance that live in each pod. You can see here that each instance has assigned the EKS prefix and the name of the pod that houses the container that launches the Payara Micro instance process. And the cluster is fully provisioned. So let's check out our service. So kubectl get service demo service, and here you can see that a specific load balancer has an external IP address, and that in this case corresponds to the DNS name of the AWS load balancer configuring the EC2 infrastructure. And you can verify this by going to the EC2 dashboard, and here on the load balancers you can see that there's a new load balancer that has been configured with an automatic DNS name and is being used by Kubernetes in order to grant external access to the nodes that were provisioned for the cluster. Let's test our application then. I'll be using this sample request by using the post method and hit the Amazon Web Services load balancer DNS name, and I'll use the data endpoint to submit a new user, which corresponds to this payload here with my name and an organization. So if I do this, And let's try that again with another user. And a separate organization. And you can see here that the requests are being accepted without issues. And finally, let's check out the data that I have sent. So this with the data /all endpoint, and you can see here that I'm getting an array of 2 values. That means the 2 users that I have created, and you can see here that one of them was created in one of the pods. That corresponds to the pod ending in KGG62, and the other was created in a separate pod, in pod S7HSC. So with this, you have a functioning Kubernetes cluster, and it is fully distributable. You can create new pods and they will automatically join the cluster. Let's wrap up. So thanks to this video guide, you have learned how to configure and provision a Payara Micro cluster in Kubernetes. The Payara platform support for Kubernetes is out of the box and it is extremely easy to understand. And thanks to the Amazon Web Services infrastructure, which allows for easy integration with these tools, you can easily create and maintain new Kubernetes clusters thanks to the EKS CTL utility and the web console. So following this, I invite you to check more videos in our official YouTube channel about other cloud topics. And if you're interested in more about Kubernetes and Payara integration, I invite you to read in our official blog site on the Kubernetes topic. So that's all for now. Bye.